Find the open intervals on which f of x is x cubed plus 3x squared is increasing or decreasing. Now, as we've talked about in the last video, if f prime is positive, then f is increasing, and if the derivative is negative, f is decreasing. This makes sense because f prime is the rate of change, or how fast f is changing. So if the rate at which, or how fast f is changing, is positive, that is, you're adding 2f, then it makes sense f is increasing. And if the rate of change of f is negative, or if f is going down, it makes sense that f is decreasing. So what we want to do is we want to find when f prime is positive or negative for this function. Well, let's start by finding f prime. We know f prime of x is going to be 3x squared plus 6x, and we can factor this 3x times x plus 2. And the reason I factored it is to find the values for which f prime is 0. Now, if you think about this, if the graph of the function does, I don't know, something like this, you see at this point the function is increasing, or f prime is positive, and at this point the function is decreasing, so f prime is negative. So at the turning point, or at this maximum, you see f prime has to be 0, because f prime is going from positive to negative. It has to cross a point when f prime is 0, and that should be this point. So what we want to do is we want to find when f prime is 0, so we know where the intervals in which function is increasing then decreasing, or decreasing then increasing, separates. So let's see how we can do that. In this case, f prime is going to be 0 when the x is 0, or when x plus 2 is 0, or when x is negative 2. So how we can think about this, we can make a chart, we can make a sign chart for f prime. We know when when x is 0, we know f prime is 0, and we know when x is negative 2, f prime is also 0. So let's see what the signs of f prime are in between these 2 points. So in this part, before negative 2, between negative 2 and 0, and after 0. Let's see what the signs of f prime are in those parts. Well, a value to the left of negative 2, we can choose any value, but negative 3 seems to be okay. And if you plug negative 3 into f prime, this thing is going to be negative, this thing is going to be negative, because negative 3 plus 2 is negative 1. So you have negative times negative, or positive. So to the left of negative 2, the f prime is always going to be positive, because f prime cannot change, because the only points where f prime can change is at negative 2 and 0. It has to be constant in between. So to the left of negative 2, f prime is going to be positive. How about in between negative 2 and 0? Well, we can try value of negative 1, because negative 1 is in between negative 2 and 0. So let's see what happens when we plug negative 1 into f prime. Well, we got negative 3 and we got positive 1. Negative times positive is negative. So f prime is going to be negative, or f is decreasing in between negative 2 and 0. Then lastly, how about after 0? Well, 1 is a value that comes after 0, and plugging that in, we have positive times positive, or positive. So as we can see, our function f is increasing before negative 2, so it's going up before negative 2, then it's going down or decreasing after negative 2 and until 0, and at 0, and exactly at 0, it starts going back up. So we know the function is increasing right here and right here, because f prime is positive. So we know the function is increasing between negative infinity till negative 2, and 0 from 0 to infinity. Now where is function decreasing? Well, our function is decreasing in between negative 2 and 0, or negative to 0. Now this is the function. Our function of f of x is x cubed plus 2x squared, 3x squared, graphed in Desmos.com. And as we can see, from 0 to negative 2, our function is increasing, and from And from 0 to infinity, our function is increasing, and in between -2 and 0, our function is decreasing.